Welcome back, everyone. In this module, we're going to take a look at first-class functions, and this is something I did touch on in the decorators video. But again, these are also known as higher-order functions, and this in any programming language is said to have first-class functions if it treats functions as first-class citizens. My note here. What this basically means that functions can be treated as variables, as values, as parameters. They can be treated like that. And this is something that you've seen before in your algebra classes. I put some examples right here as far as you learned that f of x, for instance, is equal to x plus 7. Later on, you were taught that you can say y equals f of x, and that meant that you can say f of 10 is equal to 10 plus 7 or 17. Or you could say y is equal to f of x is equal to y, f of 10 equals 17. And in fact, in many instances, they would do something like this, y of 7. So at that point now, the y, which was a variable, now was being treated like a function, if you will. We could have g of x is equal to x minus 10. We could have a variable z is equal to g of x, and then I could say y is equal to f of g of x. I could do a composition of functions, or I could say y is equal to f of z, since z is equal to g of x. So this is something that you have familiarity with. Hopefully, if you took any algebra classes, this is something that you've seen before. And I just wanted you to see that this is not a foreign concept. It's something that you've seen before and you've had experience with before. And any function, any programming language that gives that functionality to you, which is basically all of them, is called a first order programming language, or because it treats the functions like that. And these functions are called higher order functions or first class functions. So enough of that. Let's take a look at an example. I have a simple function here, square x, which returns the square of a value that's passed, and I can say f, which is a variable. I mean, you know what, a bit idiot, I'm just going to call this, say, y. Y is equal to square of 5. And if I print square, it prints the function. Notice that there's nothing that's passed. If I say print y, it actually returns 25. So if I do just square here, again, just returns the function. This is the function name here. But I can pass a value to it, and by putting those parentheses, it actually executes it for you. So now let's do this. Let's say that f is equal to square. So f is equal to this function. So f becomes a function. I can say print square, and that's the function. I can say print f, and that's the same function. You can see even the memory addresses are the same. I can now pass 5. So this is like saying y of 7 here. That's the idea when I say y is equal to f of x. This is y of 7. I can say f of 5 if I want to, and it prints 25. So f is now a function, and remember that these parentheses execute the function. So let's consider passing a function in as an argument. So I have a function called mymap, which takes a function as a parameter and also a list called argument list. I have an empty list created here called result, and I'm going to loop through for I in this argument list, and I'm going to call this function that's passed as a parameter, apply it to the value I in that list, and then append the results to this result list and return that list. By doing that, if I do squares equals mymap square 1, 2, 3, 4, 5, I can get a result back that's the square of these numbers. Similarly, I can create a cube function and say call mymap again, but pass to it a different function. Instead of passing square, I'm going to pass cube, and this is going to return the cubes of these numbers. We can pass functions as parameters. We can also return functions as variables. That's what it means for it to be first class or higher order function. So I have a logger, which takes a message, and I have another function called log message, which simply prints log and then a message from the outer function. And I'm going to return the log message, which is this inner function. Notice I'm returning the function. I'm not executing the function. The execution would require that I put parentheses in front of it. So if I create this construct right here and then create a log hi variable that says logger hi there, which is this. So it takes the message hi there, and then it goes to the inside function which says prints log and the message hi there, but it returns this function without executing it. Okay, so if I do this, I just get the function back. If I do the parentheses, then it actually executes it. So again, keep that in mind, that without the parentheses, it's just returning the function. Same idea, if I have an HTML tag as a second example here, I pass to it a tag, then I have this inner function that says wrap the text, and here's the message or the text better that comes in. And let me change this to text so it's clear. So let's see what happens here. The positional arguments of the format command, format method, this is position 0, this is position 1, so I need position 0 twice, and position 1 goes in the middle. And I'm returning the wrap text function. Notice I'm returning the wrap text function. I'm not returning this print statement, I'm returning the function itself without executing it. So if I do this, and then I have a variable called print h1 for the h1 header level 1 tag of HTML, I can call HTML tag and pass to it h1. Well, what happens? This function gets called, I pass h1 in here, then this goes in the inner function, and I have this print h1 here, and well, there is no text of any kind yet to be passed. If I call print h1 and pass the text to it, so this at this point, this text gets replaced in here, and it goes inside of this in this position, position 1. And because I have parentheses, the function gets, wrapped up like that. Again, if I say print h1 coffee time, what's going on here? Well, print h1 is this right here. Print h1 is basically a function at this point because I've assigned it to a function, namely HTML tag h1. So print h1 is a function, and it's going to take coffee time, and it's going to put it in here. This is the inner function that was returned, print h1. And it's going to put coffee time in this position and wrap it with the two h1 tags from the results. And of course, I'm going to get coffee time with h1 tags wrapped up. So let's take a look at this concept of closure a little bit more closely. I have this outer function which has a message variable, doesn't do anything with it. I have this inner function which is inside of this outer function, obviously, and prints the message. And here I'm returning the inner function, but unlike, say, this one, I'm executing it. I'm executing the inner function and returning that result. So this is the inner function being executed. What does the inner function being executed do? Well, it prints the message. What message? Hi there. And the result is being returned. So if I come to the outer function and put these parentheses and run this whole thing, I'm going to get hi there. Okay? So keep that in mind. That's what's going on. Now, if I don't put the parentheses, then I get the function, and notice it's the outer function that was returned. The outer function was returned, but it wasn't asked to be executed. So the function was returned ready to be executed, but I can, of course, execute it by putting in parentheses. So let's instead do this. So I have the same construct as before, except I'm going to return the inner function without executing the inner function. And then I'm going to have a variable called myfunc, which is equal to the outer function. So this becomes a function. The outer function is a function, and I'm assigning it to myfunc, just like saying y is equal to f of x, for instance. It's a little bit easier, hopefully, to visualize it now. So if I do myfunc, what does that do? Well, it shows that the outer function, this is the outer function ready to be executed. If I say myfunc parentheses, open close parentheses, now it says, well, this is the inner function that was returned. Remember, the inner function before we had it be executed, but now it's not being executed. So it basically executes the outer function, and the outer function being executed returns the inner function, which itself has not been asked to be executed. But what I can do is I can, and let me put a cell above here, I can say myfunc. So this returns the inner function ready to be executed, and then another set of parentheses to execute that inner function, and that's going to say hi there. And that's what closure is. So that inner function is available for us. It remembers it has access, and we can execute it later. I can say myfunc dot underscore name, the dunder name method, and it says that's the outer function. I can also say myfunc dot double underscore name like this, and that's the inner function, as you might expect. I can have myfunc be equal to the outer function with the parentheses added, which is something I did not have over here. So this is going to execute the outer function and assign the results to the inner function. So this is going to be the inner function at this point, the result that comes back. But then I can execute it here to get that inner function, because the inner function by itself doesn't execute. And as before, I can do this to get the complete results back. So I made a note over here that a closure is an inner function that remembers and has access to variables in the local scope in which it was created, even after the outer function has been done executing. As another example, final example, I have this outer function, MSG, takes a message, and I have my message equal to the message here. No, this is silly, I don't know why. Let me just get rid of that. I just passed to it a message, and I just call it a message here. So, and then I have the inner function that prints the message and returns the inner function without the execution. I can say tfunc is equal to outer function tTime. Notice that the outer function is being called with the parentheses, so this is going to be the result of the outer function being assigned to tfunc. And then I have the outer function with the results of coffee time being assigned to coffeefunc. Again, this tfunc, this is returning an inner function without execution. So the tfunc becomes this inner function with this tTime variable in there, or parameter in there, without being executed, is going to simply return the functions. It says this is the inner function that was returned, but I can execute it if I want to, and it will return tTime. Same with the coffee func. As you can see, again, if I don't put the parentheses, this simply returns the inner function because we're not executing, and then put the parentheses, we do execute it. So each function remembers the value of its own message variable. So hopefully that clarifies functions being being treated as first-class functions in Python, and what that means, and the concept of closure. Thank you for being a great audience as always, and as always, if you're enjoying these, please share with family, friends, and I'll see you in the next video.